Okay, let's just say it. C-sharp technical interviews can be pretty intense. But what if you could walk into your next one feeling completely confident, not just prepared? Well, that's exactly what we're going to do here. We're going to break down all the key concepts, the tricky questions, everything that can make or break your interview. I'm your host, and I'm really excited to help you totally ace it. We're going to cover the whole spectrum, from the deep down engine room of .NET all the way to some pretty advanced C-sharp concepts. By the time we're done here, you'll be able to tackle even the toughest questions they can throw at you. So, you ready? Let's dive in. All right, here's our game plan. We'll kick things off with the absolute fundamentals of .NET. Then we'll get into memory management, which is crucial. After that, a quick look at some essential keywords, then a deep dive into object-oriented programming. And we'll wrap it all up with some advanced topics that will really make you shine. Let's get to it. Okay, first stop, the very heart of .NET. Truly understanding how your code actually runs is what separates a good developer from a great one. This is the foundation for everything else, so let's make sure it's solid. So, what is the CLR? Think of it as the conductor of an orchestra for your application. It's the core engine that's managing everything behind the scenes. Memory, security, how your code gets compiled. It's the unsung hero that makes your .NET code actually work. So how does this work? Well, when you write C-sharp code, it first gets compiled into something called intermediate language, or IL. Then, when you run your app, the CLR's just-in-time, or JIT compiler steps in. It takes that IL and translates it into native machine code that the computer can actually understand right when it's needed. And it's smart. It caches that compiled code so it doesn't have to do the work twice, which makes everything run super efficiently. All right, let's talk about something that can literally make or break your application's performance: memory. Understanding how C-sharp handles memory is absolutely critical for writing fast, scalable code. This is a topic interviewers love to dig into, so let's get into the nitty-gritty. You've probably heard of the garbage collector, or GC. Think of it like an automatic cleaning crew for your app's memory. It swoops in and clears out any objects that you're not using anymore, which prevents memory leaks. And it's incredibly efficient because it uses this generational model. It knows that most objects die young, so it focuses most of its cleaning effort on generation 0, leaving the longer-lived objects alone. It's a brilliant system. This is a huge one: value types versus reference types. Here's a simple way to think about it. A value type, like an int, is like getting your own cup of coffee. If you copy it, you get a whole new, separate cup of coffee. But a reference type, like a class, is like getting the key to a coffee shop. If you copy the key, you don't get a new coffee shop, you just get another key that points to the same one. This difference in where they're stored, stack versus heap, has massive performance implications. So, following on that, you'll often hear about boxing and unboxing. This is basically the process of converting a value type to a reference type and back again. It's like taking a book off a fast access shelf and putting it into a big, heavy backpack. You can do it, but if you're doing it over and over inside a loop, it's going to slow you down. An interviewer asking about this wants to hear that you understand the performance cost and that modern C-sharp features like generics help us avoid it. Okay, time for a lightning round. We're going to hit some of the most common C-sharp keywords and types that you're almost guaranteed to be asked about. This is all about testing your practical, day-to-day knowledge. Let's see how you do. First up, string versus string builder. This is a classic. The keyword here is immutable. A regular string cannot be changed. Every time you think you're modifying it, you're actually creating a brand new string in memory. That's fine for fixed text, but if you're building a string inside a loop, oh man, that's a performance killer. That's where String Builder comes in. It's mutable, meaning you can modify it in place without creating new objects. The rule is simple. If you're building a string piece by piece, use String Builder. Next up, var versus dynamic. This one trips people up, but it's pretty straightforward. Var is just syntactic sugar. The compiler knows the exact type at compile time, it's still strongly typed and perfectly safe. Dynamic, on the other hand, is a whole different beast. It tells the compiler, hey, trust me, I know what I'm doing, check this at runtime. It's powerful for things like working with JSON, but it throws all that compile time safety out the window, so you have to be careful. And what about const versus read-only? They both make things unchangeable, right? Well, yes, but the key difference is when the value gets locked in. A const is burned in at compile time. It has to be a fixed value, like pi. A read-only field, however, can be assigned at runtime, but only once inside the constructor. This makes it way more flexible for things like configuration settings that you load when the application starts. Okay, we've covered the low-level stuff. Now let's zoom out and talk about the heart and soul of C#, object-oriented programming with classes. Nailing this stuff shows an interviewer you know how to build clean, maintainable, and scalable software. So a fundamental question, what's the difference between a constructor and a method? It's all about purpose. The constructor's only job is to build the house, to initialize a new object and get it into a valid state. It runs automatically when you use the new keyword. A method, on the other hand, is what you do inside the house. It defines the object's behaviors and actions, and you have to call it explicitly. Let's talk about two special keywords for classes, sealed and partial. They do completely opposite things. Sealed is like putting a do not enter sign on your class. It prevents any other class from inheriting from it, which is great for security and ensuring its behavior can't be changed. Partial, on the other hand, is like a to be continued sign. It lets you split a single class definition across multiple files, which is a lifesaver for organizing huge classes or separating machine-generated code from your own logic. And we're back to struct versus class. This is just another way of looking at value types versus reference types. A struct is a value type. Think of it like a bicycle. It's lightweight, efficient, and great for simple, small data structures like a point with X and Y coordinates. A class is a reference type. It's more like a car. It's for complex objects with lots of logic and behavior. Knowing when to use a lightweight struct can be a big performance win. Of course, classes are more than just methods. You have properties, which are the gatekeepers to your data, letting you control access and add validation logic. You have static members, which belong to the class itself, not any one object, perfect for utility functions or shared constants. And then you have indexers, which are super cool. They let you treat your object like an array, using those square brackets to access its data. Okay, you've absolutely mastered the fundamentals. It's time to level up. This last section covers concepts that show you're not just a coder, but a thoughtful engineer. If you can speak intelligently about these topics, you'll definitely impress your interviewer. First up, iDisposable. The garbage collector is great at cleaning up memory, but it doesn't know about things like open files or database connections. That's on you. iDisposable is the standard way to signal that your object holds on to these kinds of resources. And the best practice? Always pair it with a using statement. That guarantees your object's dispose method gets called to clean up, even if an error happens. This might seem basic, but it's important. What's the difference between a DLL and an EXE? An EXE is a standalone application. You can double-click it and it runs, because it has an entry point, that main method. A DLL is a library of reusable code. It can't run on its own. It's meant to be used by other applications, like an EXE. Think of it this way. The EXE is the car, and the DLLs are the engine, the wheels, and the stereo, all the components it needs to work. Finally, let's talk about handling data safely. Nullable types, that little question mark after a type like int, are a lifesaver. They let value types hold null, which is essential when you're working with databases where a value might be missing. Then there's the default keyword, which gives you the default value for any type, 0 for an int, null for an object. It's super handy in generic code. And don't forget checked and unchecked. They let you decide what happens if a calculation overflows. Do you want the safety of an exception, or do you need every last drop of performance? The choice is yours. So, let's boil it all down. Here's your cheat sheet. 1. The CLR is the engine that drives everything. 2. The stack versus heap distinction is fundamental to performance. Use structs for speed, classes for complexity. 3. Know your keywords. Use string builder in loops. Use read-only for runtime constants. And 4. Always clean up after yourself. Use iDisposable and a using block for unmanaged resources. Nail these 4 points and you're in a fantastic position. And there you have it. We've covered a ton of ground, from the CLR right up to advanced practices. But the best way to really solidify this knowledge is to use it. So my question to you is, what's one concept from this that you can explain to a teammate or a colleague tomorrow? Go out there, practice, and ace that interview. You've totally got this.